Hey everyone, it's time to start the presentation on yath, yet another test harness, also known as Test2 harness. I want to apologize in advance if my energy seems low. I have come down with quite the cold, but let's go ahead and begin. Oops. So what is yath? Yath is a new harness, an alternative to Prove, that just provides a lot of new features and is under active development, unlike Prove or Test Harness, which have mostly just been bug fixes for a while. So what are the benefits? Well, yath will let you preload your modules and your applications before running the tests so that you don't have to load them on every single test. If you have a lot of test files and your app takes a while to load, this will save you a lot of time. It has an event log that lets you inspect every detail of the test that you just completed, even well after the fact. It has different output. It doesn't default to tap output. This output is made for humans, whereas tap was made to be sort of both for humans and machines, and did pretty good, but is not perfect. Some features, one of the big ones is timeouts. You can make it so that your tests will just time out if they take too long instead of stalling forever. But please note, yath is still fairly experimental. Some areas of it are under development or might change. That said, it is being used in production at least a couple of companies, including ZipRecruiter. Testimonies. So at ZipRecruiter, our test suite under Prove with J1 takes over 4 hours to run on our development boxes. With yath, we're able to bring it down to 1.5 hours, and we're also able to bump the -J up to 3. Because yath provides some things that make running our tests in parallel possible, whereas with just Prove we couldn't without some sort of locking mechanism. And with a beefy test box with a ton of CPUs, we're able to get that test to run in 15 minutes under yath, or the test suite. cPanel has also given me a testimony to share. They have a test suite that takes about 60 minutes to run, and under yath with just a couple days of tagging their tests, they were able to get it down to 12 minutes. Questions before I move on? Yes.
There's a timeout. Is that per test?
I'll get to that later. So let's start with a quick start. Installing it is simple. Use cPanm to install Test2 harness or app yath, and it installs pretty quick and easy. So to run it, you just type yath, and it will do most of the smart stuff for you. Like it'll add lib to your inc, and it will find the tests under T, and it will be recursive by default. And this is what the output looks like when you do that. It's very similar to Proves in that your diagnostics messages will print, but most of your stuff like just line noise won't. And so it'll give you that output. It gives you a bunch of other stuff, tells you your tests were successful, tells you how long it takes to run. I'll note that through this talk, at some point you will probably see this number be negative. That is a bug I do intend to fix. You don't need to call it out to me. So the default command is to run tests. If you just type yath, it'll assume that is the command you want to run, and it will warn you that it is making that assumption. So you could just type yath test so that it doesn't warn you that it chose a default for you. It's just the same thing here. Preloading. So who here has actually sat and watched just how long it takes for the Moose test suite to run? That's quite a bit of you. Well, without preload, it takes 1 minute and 42 seconds on this laptop to run the entire Moose test suite. I've just given you the very bottom, obviously. Let's try that with preload. -P Moose, preloading the Moose module, the whole test suite finished in 43 seconds. That's a big improvement. That's no concurrency or anything magic like that. It's just preloading the Moose module. Persistent mode. For when you are actively developing, you can start a yath daemon with the preloaded Moose, and then you can run the tests directly against that already loaded one, and we can see the difference that makes. Obviously with Moose, it's not that big of a difference because it takes your runtime from 0.17 seconds to 0.04. That is notable if you're a machine, but as a human, you're probably not going to notice that difference. But if you have a company test suite where each time you run a test, it takes like maybe a minute to load your application, this makes a huge difference because you go from 1 minute per test file to less than a second. We have that problem at ZipRecruiters. We'll run a test and it has to load our app and it takes a full minute. So you can sit there for a minute before you even get any test output. But with the preload, They're instant, just instant results. And the persistent mode is also smart in that it will use iNotify to see if any of the preloads that you've loaded have changed, and it will reload itself as needed. And if you're actively developing one of your modules, like say you were making changes to moose.pm, it will blacklist it so that when it does restart, it doesn't reload that one. That way you can continue to develop it without your preloads needing to reload every time you write the file. So commands, I've just output the yath help to give a list of commands. I'm not going to go through all of these, but there's test, which we've covered. Failed. This lets you take your log that you can produce from a run and say, oh, tell me what test failed in that run I just did. Gives you a nice summary. Times. I can demo that one later. That one will give you a list of how long each test took from longest to shortest. Or maybe it's the other way around. Doesn't matter much. Bunch of commands here for your persistent mode, like reload, which will reload forcefully your runner, which will also reset the blacklist. Run is to run your test, start to start the persistent runner, stop. Which to tell you which persistent runner you're actually going to be using if you have multiple running at a time, based on which one it finds a temporary file in the tree for. And watch, which lets you look at the output of the harness separate from the output of your tests. Questions before I move on from the quick start? Okay, so let's take a look at the output. This is the default output mode for yath. The rules are very similar to prove, as I said before. If you've got diagnostics messages or errors, they will print. But if your test doesn't produce any of that output, it's just passing, it will just output a line saying, hey, that test passed. You'll notice this column here shows which job it was. That's in case you do have concurrency going. You can tell which job produced which output. Quiet mode, easiest slide I've ever had to make because quiet mode suppresses all output and only returns a true or false value. Verbose mode is all the output all the time. Here's where you can see why having the job is important. This was actually not run with concurrency, but the test moved from the first test to the second test faster than the part that was reading the results of the test, so the output was kind of mixed together. You can see just all the output all the time, even getting down to what you probably can't see here, but this tells you your memory usage during the entire run. And my favorite mode, QVF, quiet but verbose on failure. Any test file that passes, all output is suppressed except for the final this test pass line. But any test that had any failure at all will be completely verbose top to bottom, so you see all the output. And that'll be buffered, so you don't have to worry about muxing. It'll output at the very end, not the beginning. Yes, that's very useful at work. Renderers, so yath actually lets you write your own renderers. All that output you saw is an encapsulated renderer. The main renderer is actually formatter, which lets you use any Test2 formatter as your output. So theoretically, you could make it output tap, but I don't recommend it. It's pretty gross. But you could also write your own custom one. I know there's a couple efforts out there that I am not participating in, but to make a JUnit XML and a Team City renderer. Once again, they're not me. I don't know where you'd find them or what level of development they have. Also, theoretically, it should be trivial to make a renderer, but in practice, there's still a lot of work to do to make it trivial. Questions? Okay, moving right along. Features. So yath uses the Test2 events directly. Your test, when you go through yath, the default is not to have your test produce tap and then have that tap parsed. Instead, every Test2 event is output as a line of JSON data, and the harness will read in that JSON data, which means it is lossless. You're not going to lose any data that the events have, any diagnostics. It all makes it to the harness. No conversion. Your standard error and standard out are also converted to events, though obviously in that case you're not going to have like file name and line number. If you do have old tests that like say print tap, yath will detect that and it will do its tap parsing. And unlike test harness or prove, it will actually parse subtests as well, so everything gets checked. A lot of people don't realize it, but subtests and prove are kind of a hack because prove will ignore any indented lines. So your subtests aren't actually verified by test harness, but yath will verify them. So config, you can put drop config files into your project directory and yath will find them. Config file is basically just the list of the commands and what arguments you want to be used by default. .yath.rc is recommended that you put it into your project and commit it to the repo because it's the defaults you think people should use when running their tests. But there's also a .yath.user.rc if you want to override that or add your own custom ones that will not be committed to the repository. The files look like this. You can see down here. In brackets, you put the command, and then you put the command line arguments you want by default. And most command line arguments can be negated later. So you could like say preload moose here, but then in your user RC say no preload after all. Timeouts. There are two types of timeouts in yath. There's the event timeout, which means if your test produces no output at all for 60 seconds by default, yath will go, oh, this is probably hung, and it will kill your test and report it as a failure. You can configure that in a couple ways. One way is at the command line. You can specify in seconds a new timeout. Or if you have a very specific test that needs a longer timeout, you can add this comment to the top of the file and give it the new timeout so that that test has a longer timeout than all the others or the default. Then there's the post-exit timeout. This is needed because somewhere along the line someone had the bright idea of having their test fork and exit while the forked process continued to produce output, which means you don't actually know when the test is done by checking for an exit value. And unfortunately, I did actually have to support that. So the post-exit timeout only takes effect if the test has exited, but it still seems like it's supposed to produce output, such as the plan isn't met yet, or there's no plan yet. Then it'll wait so many seconds before going, you know what, no, this is probably dead. And you can configure that as well the same way. Questions about the timeouts? You can also disable a timeout completely with these comments. I'll show that later. Yes?
So under the hood, are you using like system level signals or?
Yes. Under the hood, there's a lot of complicated stuff going on here. And by the way, yath does not fully work in Windows yet. An old version did, but we broke it somewhere along the line. That will be fixed at some point, but it's not a priority. But BSD and Linux, it works pretty well. So in test directives, there's a lot of these comments that you can pop into your tests to actually control how the harness treats your test file. You can set a category that is useful for scheduling. So if you set the category to long, it'll go, oh, this is a long test. If you have concurrency, so more than one process at a time, it'll do the long tests first for n-1 processes so that at the very end, you're not sitting there waiting for your long test that started last to finish. So it should reduce the amount of time it takes to run. Stages I'll get into later. You set the timeouts. You can add metadata up here. Or you can also control other things, like it said, yath can preload, which means it has to load modules and then fork to run your test. If you have a test that does not work with forking or preload, you can say, hey, harness, don't fork for me or don't use preload for me. I need to load it myself. And it'll honor that, and it will start a brand new process to run your test. No timeout to disable timeouts. You could also do harness no stream to say, oh, you know what, actually I should produce tap output and you should parse that tap. Don't use the JSON formatter. Here I set it to use just to show you the syntax for if you wanted to enable one of these. But all of these are actually enabled by default. Categories. So the general category, which is the one it's put in if you don't specify anything, is just normal test. Immiscible. You use this if you've got a few tests that absolutely should not run concurrently with each other. And yath will go, oh, hey, look, this one's immiscible. It can run with all these general tests, but it cannot run at the same time as this other test also marked immiscible. Isolation is similar, except that this test cannot run with any other tests. So I don't care how parallel you are, wait till all the parallel stuff's done, then run this one alone. Long just tells you it's long. Medium at the moment is an alias to long, though that might change. Long is not very descriptive. Is long 5 minutes? Is long 10 minutes? It depends on your test suite, so it's all relative to your test suite. And you manually have to tag that. There's also various configuration. I've already talked about most of these, so I'm just going to scroll through them. So harness no stream is an alias to harness use tap. Questions about the directives before I move on, because that's quite a few slides there. Nope. Tempter. So yath uses a single temporary directory, a work directory, where it puts all its data and all the output from the files. When requested, you can actually put this on SHM, which sometimes provides a speed boost. It doesn't do that by default because that actually seems to eat up a lot of memory on a lot of CPAN testers. And every test that yath runs gets its own temporary directory under the main one, and its temperature variable is set. This means when yath is done, it only needs to wipe out its own workdir to ensure all temporary files, if they were created properly, will be cleaned up. You won't have garbage left over in your temperature. There's notification options. You can have yath email you the results of a test run, or you can, in specific tests, say, hey, this test is owned by foo@example.com, and if you provide the email owner link, then whenever there is a failure, you will get an email about it. You could also disable that. There's a lot of things there. You can also do Slack notifications by giving it a Slack URL for the Slack API and tell it what channel and what user, or you could also, I didn't put them here, but there's directives to list which Slack user or channel owns a certain test. And these are useful because if you've got an automatic test runner somewhere in your company, you can have it automatically email or ping the right people when one of the tests has failed in the automatic runs. Questions about that? Yes?
Test temperature timing keeps the temperature directory around if a test fails. Will this block that functionality?
It might, but there is options to yath to tell it to keep the data. I'm actually going to show you one of those a little bit later in a live demo. But you have to ask for it in advance. It would be good to have an option to keep for failing tests. So advanced preloading. If you have a module that you preload and its subclass is Test2 harness preload, it has several hooks available that will be called at the right time, such as pre-fork. If you want behavior that happens just before you fork to run your new test, post-fork, which happens right after the fork in the new test, pre-launch, which happens after a bunch of state is cleaned up after the fork, because you can't just fork and run a test. You have to do things like reset $0, fix the data handles, bunch of stuff you don't want to have to deal with that yath does for you. And note, if you were at my lightning talk yesterday, at the very end, after forking, it uses goToFile to make sure there's no extra stack in your test. There's the preload method, which lets you then, like, say, require all the modules you want. So if you've got like 1,000 things you want to preload, you don't have to list them all at the command line. You can create your custom preload module and have it load them in its preload method, and then just request that this module get preloaded. And that you can drop into your .yathrc. Stages. This is when you have really complicated preload needs. For instance, at ZipRecruiter, we have several stages. First stage is load all our CPAN dependencies. Second stage is load all of our basic modules from our framework. And then we've got two other stages for a couple different apps that we run. And these stages, it'll run one stage, so preload all the CPAN stuff, then run all the tests that are in that category, or not category, sorry, in that stage. Then after those are done, this is assuming no concurrency, it will preload all the base modules and then run the tests that they're supposed to run in that stage, on and on. App and App 2 are not actually built on top of each other. They're both built on base. And my next slide will explain how I do that. But before I move on, these stages are also smart if you've got the persistent runner. The persistent runner will actually have a process for each of these stages sitting there waiting for tests to run. That all works. And if you change one of the modules that one of the stages uses, it will notice that and roll back all the stages that did have that module loaded and reinitiate them. Tiny bit buggy, but it seems to work pretty well. So fork stages. This is one where you can say, hey, these stages that I'm about to return as a list, fork before starting them so that other stages that come later do not build off of them. They are independent. It's not a lot of control over that. So we get to the future slide. I'm intending to overhaul this a little bit. None of this will go away, so you could go ahead and start using it. But in the future, I'd like to have a more intelligent system where you can specify a lot more directly what you actually want out of the stages, where you don't have to require the preload modules yourself. You can just list them, that kind of thing. So that's coming, and that might be a nice DSL to help you define those. Questions about the preloads? Okay, I can't tell whether there's no questions because I'm not making sense or because I'm making too much sense.
Just the right amount.
Sounds good. So I'm afraid to say that after this point, I did not have time to finish all my slides, so they start to get a little bit janky after this, where I do a lot of live demoing. So you can do plugins. Here I've done the very basic plugin that does absolutely nothing, just so I could talk about it. Define a plugin, you inherit app-yath plugin. That's because plugins are not for the harness, they're for yath, which is the command line tool that uses the harness. Complicated, but there is a division between the two. There's the harness and there's the command line tool. They are very separate and have separate namespaces. One just uses the other. But plugins let you create your own command line options, such as if you didn't like my notification stuff, you could write your own notification module with its own command line things and have your own Slack plugin or IRC plugin. Some stuff for pre-initialization, post-init, post-run. Post-run is really useful if you want additional output once yath is done doing everything, because that happens just before exit. And I didn't put the arguments here because, frankly, I can't remember what they are, but you do have all the data of what tests failed, why they failed, all of that. So there's a lot you can do in there. There's hooks to help find files. Like if you don't want it to just start searching the T directory, you can implement a custom find files and it'll go find the files for you. Munge files lets you modify its understanding of the test files before it actually tries to run them. You can completely block the default search, or you can claim a file and say, oh, this file you found, I actually need to do something to it before you can run it. So these plugins provide a lot of power, but I don't have a good example of one to show you. But if you have any questions, I'll do my best to answer them. Once again, okay, easy crowd. Layout. Here is one of those dreaded live demos. I'm about to run this command, which I briefly mentioned earlier. It's going to completely keep the temporary directory so I can walk through it with you. I hope you can all see this. I'm not going to make it bigger because then I can't see it. So this is just like I said, it's not meant to have such a low resolution here, but so this is the just a bunch of tests that I threw together for this. So it says it's keeping this temperature. So let's go into that temperature and take a look. We can see here there's a directory for each test that was run, done by ID, UUID, sorry. But then there's a bunch of extra files. PID is the PID of the harness. Complete is just a file to say, hey, this run is complete. Some of the more useful things, error log, empty because nothing really failed. Interesting ones, there's the queue and jobs. The queue is basically each test file that it was going to run and then a null terminator to say, hey, they ran. So this is a JSON-L file. Each line is a self-contained parsable JSON string. So you can see like job 3 had this long ID I don't want to read to you. Timeout set to 1. Basically, you can see all these details, including what the test actually was. A lot of data about it. And if you go to the jobs, it's similar, except there's a lot more data attached because some processing has been done. But that is actually, these files are actually used by yath to queue what tests are going to be run and then run them until when they're done. And so when you go to concurrency, there might be a lot of different processes actually taking a peek at these files, locking them, and modifying them. So let's see, what else is interesting in here? Run. Oops, I'll just open it. Run.json talks about the overall run, like, we added the lib directory to add inc, what plugins, what preloads, that kind of thing, what the concurrency was set at. So all the metadata about that run you just did. That's about it for interesting files there. So let's just go ahead and jump into one of these projects. So the files that come here, there's exit. So once the file exits, its exit status will be written to exit. So in this case, it exited 256. So I'm guessing this was the fail file. Then you can cat the file to see what test. Yes, I was right. Fail. Start is a timestamp to show when it started. Basically, all the metadata you'd need. All standard error and standard out was redirected to these files here so that I could parse those. You'll note there's some information here you didn't see before. I'll get to that in a minute. I forgot that was in there. Also, with yath, you can specify input for the test. So standard in was a file handle that was set to be the standard in for the test before it was executed. Now the interesting bits. Oh, so you can see the temp directory down on the far right. That is the temp directory that was set to the temp variable. So events.jsonl. All the test2 events that were produced by this test are in here in their complete form. You can see the stamp, the event ID. If we go on, we get to the point where we see all the facets. If you were at my talk yesterday, you'll know what those facets are. So we can look in here and find an assert. Oops, if I can spell it right. There we go. Pass 0. Details, a deep failure. So you will notice that, where is it? Oh, I don't see them there. But anyway, if we go back to standard error and standard out, you'll notice it's got these lines, async. These lines don't actually get displayed to you, but every time an event gets written to events.json, one of these lines gets sent both standard error and standard out. This way, we can actually synchronize standard error, standard out, and the events, so you don't have the problem where you've got your test failure up here, your diagnostics here, and then the actual other details about it, standard error output, all the way at the bottom. And how many of you have looked at prove output and gone, why is my error up here? Why is my diagnostics over here? That doesn't happen with yath because it sends all these synchronization messages so it can put things back in the right order when it's done, even though they're sent to separate outputs. The only way to fix this with prove is to merge your standard error and your standard out, at which point you can't tell which one came from where anymore. Yath solves the problem so that neither of those are issues. You've got synchronization and you have separation of sources. Thank you. So that is the layout of the directory. Sometimes there might be a few issues with some tests that actually expect their standard in or standard error to be actual streams as opposed to files. So you might have to make a few adjustments for that. In practice, I think we had one of our tests at ZipRecruiter have that problem. I think cPanel had 2 or 3, but they were able to fix them. Hardly worth noting. Any questions about the directory layout before I move on? Okay. Log tools. So yath is able to output a log. You saw I showed you the events that each job produced. The yath log includes every event from every test, including the events of, oh, I'm starting a new test, or I'm ending a new test, or even, oh, I just preloaded this thing. Absolutely every event is in the order that yath originally saw it to process it, and it goes into this log. This log has everything you need to fully inspect beginning to end any test run that happened. It doesn't happen by default, but you can ask for it with the -L, or if you're stingy on space, which you probably should be, these can get huge, you can use the -B, capital B, sorry, which will automatically output it in bzip format, or bzip2 format from the beginning. So like if the moose log were 300 megs, which it might be, it'll go down to something like 5 megs. Really useful. So more. Once again, didn't have time to finish this, so we get a bit of a live demo here. I will pop up here. Oh, no. No, there we go. So let's keep a log. There we go. So I can pull up the log. Wow, 3 lines on the screen, 2 lines on the screen. There we go. It's exactly what you'd expect. Just a JSON-L file, tons of these. Use JSON-L because that means you don't have to parse the entire file beginning to end to actually look at this. You can look event by event by event, reading the file line at a time and parsing just the lines you care about. Really handy, not needing to parse the entire 300 megabyte JSON file. Though in this case, it's only 50 lines because it was a pretty small test suite. So that's that. Now watch this. Actually, I'm going to move to Moose for this one. Looks like I've got plenty of time. and I'm in the wrong directory. There we go. So you can see here, just beforehand, I ran the Moose suite. Let's actually just go ahead and sit through it again because it's so quick with yath. It's just about 30 seconds. Oh, horrible tiny screen. Tiny resolution here. But it actually does show you that it handles it okay.
How does
Ouch.
Moose do in Perl?
What?
How does the Moose test suite do in Perl?
The Moose test suite does really well in Parallel. In fact, why don't we cancel that? J5. Oops, J5. Why not? See just how long that goes. Look at that. There we go. Running through the Moose test suite insanely fast. This output is really awful. I really want to, for a moment, go to a better resolution just so you can see what the output looks like on a human level. And then we'll come back to the higher resolution. So there we go. Oh, let's start again. That took 20 seconds, entire Moose test suite. But here's what it actually looks like while you're running it at a decent resolution. It's showing you which ones are in parallel at the bottom, showing you how many events we're seeing, and the stuff is scrolling up. So that's good.
What's the significance of the job color there?
It's mostly randomized just so that it's easy to tell the jobs apart. It's got like 20 presets in it. It sort of shuffles through them. The color is only for human readability. And you can disable the color. Color will be automatically disabled if you redirect output to a file, that kind of thing. Okay, so now I'm going to go back to a font you can all see, now that you've seen it pretty. So, so we saw that. Took 20 seconds.
Question?
Yes?
No record to that guy with his hand up.
Oh, yes.
So you have JSON output here, the JSON out. What happens if somebody inserts a weird non-UTF-8 character into a test name and then it, say, ends up in JSON? How do you deal with that?
I do. I don't remember the technical details. I do remember it did cause problems initially, and I worked through to get all the encoding stuff right, but I couldn't remember how right now. It works.
We have that problem all the time, and I'm not even thought about it.
Yes, so one of the problems with yath actually right now is it doesn't have very much unit test coverage. Ironic, I know. It's been under such rapid development. Its test suite is pretty small, but we do have tests for that. Okay, so I mentioned the replay command. We can replay that entire test run from this log. And this is actually big. Oh, there we go. Took 2 seconds to replay because we didn't actually rerun any tests. But another nice thing about this, let's say we only care about this test. Replay just that. And it'll sit there and then boom. We didn't even get the output for that one. Oh well. I need to give it the ID of the run, not the file, which is something I will fix. But like if only one of your tests failed, you could ask it to replay just the events from that one test. There were no failures, which is probably why there weren't anything output. But if we switch back over here, so this one did have failures, and here it's listing which one failed. So I could do yath replay, the long-ass log file. That one was 3 lines. And then give it just the ID of the test that we care about. And there, it only showed the output of the failure. Thank you. And it did not rerun that. You don't need the source for your tests or your modules anywhere near there. You can just have someone email you this log file, and you can replay the run as verbose or as quiet as you want.
I think that does answer the question I was going to ask, which is you can do your initial run relatively quiet, and then come back and just replay the log to get the details for just the ones that failed.
Yes. So the question was, can you do your test run completely quiet, and then when it's done, just replay the log to get the details? Yes, you can. Also, thank you, been working a bit with the CPAN testers pre-action, and at some point, it might be such that these logs can be automatically uploaded to CPAN testers with your reports. So another thing to actually go over in that case, there's the yath init command. What yath init will do is it'll drop a test.pl into your project that will use yath to run all your tests. If you then rename T to T2, then that means CPAN testers will only run that test2 or that test.pl, which will then call yath to run all of your tests so that you actually get the yath output on CPAN testers instead of the prove output. That is sort of a hack just because CPAN testers does run test.pl and only looks at its exit value. So it's not necessarily ideal, but assuming we actually get out of experimental mode, it might be possible to request or even put in your build tools like dzil, hey, this one should be run by yath, at which point you'll get all of these nice diagnostics and logs and everything else. So let's show a few others. How am I doing on time? 15 minutes? Okay, cool. So we can do yath times, let's go up to that line, into this tool. Let's upload that and go back to our dashboard. Here we can see it pulsing because it's running. Let's take a look at the parameters here. This tells us everything about our run in a much easier format than opening it in Vim. We've got a run ID. We see that we ran it with J5. Some stuff you don't need to know about. We preloaded Moose. We searched the .t directory, or just the T directory. These are the environment variables that yath set before running everything. Default search path. These are the lib directories that were added. We are using the unsafe ink by default, and we are using fork to run the tests. Okay, so this should be just about done here. Yes, it's turned green. It's all done. So we're going to actually jump into the logs. So first off, we still have the build up here. We can get to all that data we had before, but we can also look here at all our files, and it'll tell us how many passes there were, how many failures there were, and you could look at the internal log. There's nothing in this one, so I'm not going to open it. But let's go ahead and open this one here. So this is the test output in all its glory. But you know what? I don't care about all those passes, so let's just hide those. Now we're seeing what the plan was, we're seeing the memory usage and the time it took to run it, and all that's in there. So let's go to a more interesting one. So fake, this is one that was a fake log, so it didn't work at all. Let's go to this failure one here. Let's take a look at this failed test. So here's one of those bugs. Note that some of these tags got put on the wrong side there. But, so this was a failure. We don't care about all the passes, so let's hide those. We don't care about the plan. We don't care about the memory. We don't care about the time. So now we've just got the failed assertions, and we've got the diagnostics and the reasons things failed. We can do nice filtering there. So let's take a look at large to see when we get some really complicated stuff. So this, there we go. So this is long enough that because of the limitations of Chrome and how many things it can put into this type of structure here, it's not a table, it's a grid. I actually had to separate them by pages where you can turn pages on and off, or Chrome would not render it properly anymore. But let's go ahead and hide all the passes and the plan, time and memory, but keep the diagnostics, the failure, and the reason. And now let's go ahead and show everything. We've now, so, you know, can choose which ones we see. Let's show everything now that we've filtered out noise. Here we go. This test that failed had subtests. You can see that here by this plus. Let's expand it and look at the subtest. Note it's loading all the stuff that was in that subtest. There we go, but we're only looking at the failures. So we don't have to look at all the other line noise there. So now these events, you can look at fine details of them as well. Here we go. In nice readable format, unlike the previous log, we can see the assert, that it was called failed, that it did not pass. You can see some random harness stuff. Look at this. We can see that it was in large/fail.t, line 11, that someone used the OK tool from the basic tool set. It was done in package main. Here's the PID. It was nested because it's in a subtest. All that good stuff. We get all that data there. Diagnostics. Let's take a look at one of those. Get down to the info, and here we can see failed test fail at large line 11, whatever. And you can do that for any event. Events in a subtest you actually get twice. First you get it while it's running, and then you get it as part of the ultimate subtest event. So you can actually see both of those here. So the one that's off on its own, not embedded in a subtest, is called an orphan. You can look at the orphan data right here. You can see it's got a little bit less content. You might not be able to see that, but it does. I think that about covers it. So any questions? No, this tool is on GitHub, but it is not on CPAN yet, and it's got a lot of work to go. Question?
Yeah, there's a test class moves feature where you can run a specific test in a test file. Is there something like that where you could run a subtest, a name subtest?
So yes, but that has nothing to do with the harness. That is a feature of Test2 if you use the spec tools to do your subtests as opposed to the regular subtest tools. Should have covered that in my talk yesterday and did not, but it has nothing to do with the harness. Other questions? Yes? No? Okay, you.
Can you call yath on a specific T whatever subdirectory test file?
Yes.
Okay, this is definitely a test 2 question. Seeing as we know what it said. If you upgrade to a new version of test simple that uses test 2 rather than the old version, and you start seeing white character and print output in the test runs, is that like a common bug that you've seen before? Or to something wrong with the test script that needs to be fixed?
I have not seen that. It could be a bug. File a report. Okay. Other questions?
I'm still using test more for Perl, and it usually takes about an hour to run the 4,600 tests that we currently have. So I'm not using Moose or any of that crazy high magic stuff. I mean, this is what you might consider to be medium or low magic tests that are running. Would this benefit in speed in any way from your new system?
Potentially. It's hard to say with the Perl stuff. I haven't looked enough into it. I'm pretty sure go-to-file will not work on Perl. So you probably won't get any benefit from preloading. But some of the other harness directives, such as saying, oh, this test needs to run in isolation, might allow you to increase how parallel you can be when running your tests, and that could potentially still work for Perl. But test more, if you've upgraded to a newer version, uses Test2 under the hood, so you will still get the benefits of the new facets and all of that. And the better diagnostics. Well, some of the better diagnostics. If you're still using Test More, you're still using isDeeply, which doesn't have diagnostics that are nice. But all these details about the events you should still be able to get just for free.
So the speed up would not necessarily be in a serial speed up, but it might give me a parallel speed up.
Yes.
Okay, thank you.
Yes. And until you make go-to-file work in Perl.
Until we make it work.
There we go. Okay. Other questions? Hand up? No? Okay, then that is the end of my talk.